Hey everyone, warm afternoon, and myself Gathin, Devrel at Zero G. So initially we had Will to join us, but I'll be taking over his position today to give you a small keynote on what Zero G is and what we do as an intelligent layer 1 chain. So just to give you a brief introduction on what Zero G is, Zero G is an intelligent layer 1 chain for on-chain AI. That means we have a complete stack that is required for you to bring AI to blockchain. So yeah, Zero G is the first intelligent layer 1, and we do have 4 core components on top of us. So that is like we have an inbuilt, so we are like a EVM compatible chain. On top of that, we have a storage network. We have a data availability layer and also a compute network. So basically, we have a complete stack that can help you on onboard applications that are native to AI, and we give you a modular solution to bring in and integrate with Zero G's tech stack. This slide is going to take some time, and I would love to give you a deep dive on how our chain and architecture looks like. So this is our complete chain architecture. So this has all the components that I mentioned previously, and chain lies that's like an infinitely scalable component that lies as like a base for the complete stack. On top of that, we have the DA layer, compute, and service marketplace. So we are a modular chain, so you will be able to utilize individual stacks of Zero G, or you could use the complete stack to power your AI application. So currently, we have, on top of chain, we have like 3 core pillars. That is the storage, DA, and compute. For the storage, we will be able to upload large-scale data sets, models, assets, and vectors. And we have achieved recently using a framework research from our team called DiLocoX, with which we have trained and upload 100 GB plus parameter model onto Zero G's network. Moving on to data availability layer, this acts like an off-chain verifiable solution for like provenance and accessibility. And we have compute network that is like the heart for Zero G's complete stack. So in that, currently we have inferencing live. We will be soon working on like the training RAG and agent support. So with which we get like currently we have few models hosted on top of it, which I will dive deep into the next slides. But this acts like a base foundation. And to utilize all these, we have the service marketplace. On the service marketplace, you will be able to interact with all the AI models, interact with the storage. You will be able to fine-tune the models, and that acts like the top layer. And finally, we have the alignment nodes. We did a node sale last year, which acts like we give the power and ownership for the community to verify all the functioning of Zero G's different node structures. So you will be able to verify the validator nodes functioning, the storage nodes, the input-output verifiableness. So we currently have the functionality given to the user's operation. So in this presentation, I'll dive deep more into like the storage and compute, and I'll just give a brief into like the DA and chain as we dive deep into these architectures. We do have like a weird output, but I'll just give you a quick thing that the thing that we face problem is with the traditional cloud storage and other decentralized options. So with traditional cloud storage, what you experience is that you are logged into a cloud provider, whereas with other decentralized options, they aren't in a way that is needed for you to bring AI on chain. So what is that with AI? You will need to have high throughput. The other thing is you have like large scale, bigger size data sets, which exceeds into like terabytes of data. Uploading that on chain will cost you like, it's really expensive. And more than that, it is not feasible in terms of like you being able to upload it completely without any issues that you face throughout the process. So what Zero G storage achieves is that we are a decentralized network that is fast as AWS S3, but still we claim that we are 95% lower cost than other centralized providers. You will be able to get instant retrieval rates. You can upload both structured and unstructured data. You are universally compatible, and you can also include like terabyte scale workloads. So I'll just dive deep into like something off topic here. So the issue with centralized AI here is that the data, the compute, the servers that are being used, the inferencing, everything lies behind a black box. So you aren't aware of, for example, if you interact with ChatGPT on your day-to-day basis, you aren't sure that the output you receive from the model is completely generated by the model itself. It can be tampered. It can be like paid externally. You aren't sure with the trustlessness aspect. So that is where we bring in zero-G storage. So this zero-G storage, you will be able to see like the complete process of you uploading model on chain. And when it's connected with DA layer and compute, the other verifiability for like inferencing, for you interacting with the models, comes place in that. So this is like a brief technical architecture of how zero-G is able to achieve the fast throughput and also like the low latency and cheaper cost. So initially, when the data is passed into like the zero-G server, it is split into multiple small chunks using a process called as erasure coding. So after that, the data is dispersed into like two different parts. One is like the storage lane. The other one is like the data publishing lane. On the data storage lane, the data chunks are distributed among multiple storage nodes on the zero-G network. And each node signs and verifies the data, the random data that it has received. And this randomization is done using verifiable random function, or VRF. So when the data is like, now currently the data is split into chunks, it is uploaded to zero-G's network. So after that, the nodes sign the data, and all the signatures together form a Merkle tree. And the Merkle root is published, or like a data root commitments take place on zero-G's chain, and the consensus verifies it. So when you do this simultaneously, you split the execution and the settlement part of the zero-G's storage. So erasure coding is splitting data into multiple chunks. And finally, the consensus on the zero-G networks or the validators verify that the data is authentic and that this root hash has like the complete tree under it, which can map the complete data which was uploaded. Moving on to zero-G's compute. In today's world, like zero-G's compute is just like a framework with which you will be able to get verifiable inferencing from decentralized GPU. So the existing compute network providers, or like the centralized one, are like high cost, and we have like complex setup. For you to upload a GPU, you need to set up the cloud infrastructures for it. And obviously, like the vendors lock-in takes place, that the migration part is the biggest difficulty that users experience when they go with centralized cloud providers. So the result is that AI computing remains inaccessible for developers and startups. So what is zero-G compute and how we are solving it differently with the market, and also how we utilize the complementary stack that we have to make this much more efficient. So the decentralized marketplace where GPU owners are selling their computing powers, and there are AI users who utilize this to get verifiable inferencing from the models. So let me break down with a small example. So you are users, and there is like a meme generating model. A meme generating model, for example, there is a model which was trained by a particular organization, and they hosted it on zero-G's inferencing. This model can be fine-tuned like a person A or B. A has did like a basic inferencing fine-tuning, so he charges cheaper cost. Option B, he like did like really intensive fine-tuning, so this meme is dedicated for like a particular instance. For example, just you to get like some crazy memes on crypto Twitter. So this one, he charges a bit higher inferencing costs. Option A, he charges cheaper inferencing costs. With current centralized providers, you are intended to use a particular inferencing for a particular model at a particular cost that's being charged by the centralized provider. But here, the model is flexible. The training that is being done on-chain is flexible. And there are like multiple inferencing providers for the same model. And also, there are like multiple models on top of this. So this creates like a complete marketplace for you, a marketplace of models, a marketplace of inference for each models. So this is like a big architecture, but this revolves around the brief architecture that I mentioned. So basically, user need not go and pay and sign each transactions when he interacts with each models. For example, currently we have models like GPT, OSS, Quen, DeepSeek. So if you want to interact with those models, all you need to do is like, we have a token named 0G. So you need to make like a common deposit of 0G to the compute or like the smart contract that handles these compute. And what it does is, based on your interaction with different models, it auto-debits the amount that is required for the inferencing cost. So with this, we are abstracting the use. Like, the one thing that you may find is like, I would use ChatGPT, and this brings much more complexity in the process. But if you are already considering the verifiability, the trustlessness, the censorship resistance over here, the one other thing as a user or for the user experience that you might think you will face is that I need to sign each transactions. It will take much longer time for me to process the data output. But with 0G and with the previous tag that I mentioned, you can get instant retrieval and high throughput. You no need to sign each data transactions, and the amount you no need to pay it for each transaction as well. So it is auto-debited from your ledger account. So with this, what I would like to conclude is that you get to interact the way you interact with centralized model providers without any latency effect. So this is just an architecture diagram. The final verification proofs are getting stored on chain. The user creates a request and signs the data. And the user deposits a certain amounts to the smart contract. And the final computation takes place from the models. So yes, that is how the user workflows takes place. From depositing of the funds, you request the services, and you get the result, and automatic payout takes place. So as we mentioned, we will be soon enabling like the RAG support, on-chain training, and agentic frameworks as well. For the GPU owners who are currently interested in like hosting your own GPUs on top of us, so currently if you want to upload your own providers, you need to have like H100 or H200 GPUs. So what you need to do is like, you need to list your GPU specifications and availability on the marketplace. You can set your own pricings. The job allocation will ensure that, automatic job allocations will ensure that your GPU is fully utilized. This is similar to like the job scheduling that takes place in networks. And you get instant earnings based on your users' utilization for the inferencing. Awesome. So I know we just gave you like a brief introduction on what 0G is. So this would give you like a Kickstarter to understand what and how we are able to give you a complete infrastructure that can bring AI on chain. So I hope this presentation gave you a good insight. So we have a booth right in this hall, and at the first booth that we have over there. We have our team over there. If you have any questions or you would like to know more or have anything specific, you can just reach out to us over there. And this is like a QR to my Twitter. So you can connect with me over there, or we will be at the booth to help you out. And hope you had a good time, and looking forward to chat with you all soon. Thank you so much.